Welcome to the lesson on net ionic equations. So the first thing we have to look at are ionic equations. Net ionic equations involve those chemical species which are involved in a chemical reaction. And the thing that we're going to focus on is eliminating the spectator ions. Now, what are those? Those are ions which do not actually participate in the chemical reaction. They're there, but they do not participate. So we know what ionic equations are. We've been doing this. So if we look at the molecular ionic and net ionic equations for the reaction of calcium chloride and sodium carbonate. So when we write this equation, we get CaCl2 plus Na2CO3 to produce CaCO3 and NaCl. Don't forget, you have to look at your solubility tables, and if you look up calcium carbonate, this is going to be a solid, and if you look up sodium chloride, this is going to be aqueous. So we know this reaction is going to occur. The next step is to break apart this equation into its ions. So if we take this right here, we have calcium chloride. We know calcium is Ca2 positive. We have 2 chloride ions. Now let's move on to the next one. We have 2 sodium ions, and we have 1 carbonate ion. So this is, these are the ions for the reactants in the equation. Now we have to look at the products. We look at CaCO3. This is a solid. This cannot, or does not, break apart into its ions, so it stays as a solid. However, sodium chloride is aqueous. We have 2 sodium ions, and we have 2 chloride ions. So now, we have a net ionic equation. And you may ask, well, where do we get this from? Well, let me just get rid of some of this here for you. Now that we have our ionic equation, if you look, 2 chloride ions. We have 2 on this side, and we have 2 on that side. They cancel each other out. We have 2 sodium ions, just like we have 2 sodium ions. What we have left, though, we have calcium ions, which there are none over here. We have carbonate ions, which there are none over here. And on the product side, we still have our precipitate. So our net ionic equation comes from what we have left. This ion and right here and this ion right here, they cancel each other out on both sides. They don't really do anything. They're called spectator ions. So these are your spectators. And we just kind of ignore them. So let's look at an example. If we have, for example, AgNO3 plus, say, potassium chloride. The first thing you need to do is figure out what reaction will take place, and this is a double displacement. So you will have potassium nitrate, and you will have silver chloride. If you look up the solubility tables, you will see that potassium nitrate gives you an aqueous solution. Silver chloride will give you a solid. It is insoluble. You have to then make sure that it is balanced. We have one silver, one nitrate, one potassium, one chloride, one chloride. Now that we have a balanced chemical equation, we now break this apart into its ions. So we know that Ag is a positive ion, plus NO3, which is a negative ion, plus potassium, which is a positive ion, plus chlorine, which is a negative ion, and that produces potassium plus nitrate. I'm running out of room, so I will put it here, plus this is now a solid. It does not dissociate. It is not soluble. So it stays as AgClS. Now that we have our net ionic equation, we have to write our total ionic equation. So anything that's on each side of the arrow will cancel each other out. Let me just use a different color. Potassium is on this side, potassium is on that side. Nitrate is on this side, nitrate is on this side. So what we have left is Ag plus chloride to give us AgCl. I will do one more example. Mg NO3 2 magnesium nitrate plus sodium carbonate. So based on what we know, a double displacement will occur. So the two metals will switch places. So you will have magnesium carbonate plus sodium nitrate. You have to look up the solubility tables to find out which one will be the solid and which one will be aqueous, or if both will be aqueous. In this case, however, this one is insoluble, so it is a solid, and this one is aqueous. And I can't fit it in there, but I'll just put a little A. Okay. Now, the next thing, you have to make sure it is balanced, and it is not. We have one magnesium, two nitrates, but we only have one nitrate over here, so we needed two. That gives us two sodium, and then we're good. So we have 1, 1, 1, 2. Okay. Now we need to break it apart into its total ionic equation. I think I said it incorrectly on the last one. Total ionic is everything. So we have a magnesium ion, which is magnesium 2 positive. We have two nitrate ions. We have a sodium ion, two of them. And we have a carbonate ion. On the other side of the equation, we have our solid, which does not dissociate, so it stays as is. And we have our other aqueous product, which we have two sodium ions, plus we have two nitrate ions. So again, to recap, this one dissociates into its two ions. This one dissociates into its two ions. This one stays as is, and this one dissociates into its two ions. Now we have to get rid of anything that is on both sides. They cancel each other out. We have 2 sodium here, 2 sodium there. We have 2 nitrate here, and we have 2 nitrates there. You will have, if it's a balanced chemical equation, that will be balanced as well. So what you are left with, magnesium plus carbonate to give you magnesium carbonate. So this is your total ionic, and this is your net ionic. If you have any questions, make sure you ask me on Friday. Have a good day.